Hello, welcome to ANS Solver. This is the sixth question on the paper. So as you can see, the variables x and theta satisfy this differential equation question. My x as 1, theta is 1 upon 3 pi, and I need to obtain an expression for x in terms of cos theta. Okay, so now what I basically do is I can basically write this in the variable separable form, which means I can keep the x's together, which is 1 over x plus 2 dx, which is equal to cos half theta over sine half theta d theta. So this is called the variable separable form, keeping the x's together and keeping the theta together. Now what I need to do is I can simply integrate both sides. Okay, now I'll just split this into, yeah. So now what I do is integration of 1 over x plus 2 is simple. First write x plus ln x plus 2 with 1 over the coefficient of x, which is 1. So you get ln x plus 2 only. And now how do I integrate something like this? I use something called as the integration by substitution, where I take my u as sine half theta. Okay, I take my du by d theta basically as the differentiation for sine. I know is simply cos, so it's cos half theta into, because of the chain rule, I need to multiply it by the differentiation of half theta, it is half. So I get this as du by d theta equals to half cos half theta. Okay, so now I can simply write this as 2 du by cos half theta equals to d theta. Okay, so now in the place of d theta, I can simply substitute. What I can do is I can write it something like this. I can write this as cos half theta over u, and in the place of d theta, I can write 2 du by cos half theta, where I can simply cancel this to get basically 2 into the integration of 1 over u du. This is basically 2 into the integration of 1 over u, which is ln u. Now I know my u is simply sine half theta. So I can write this as ln sine half theta. Okay, but after integration there's a plus c, because this has no limits, it's an indefinite integration. So now writing everything together, I can write this as ln x plus 2 equals to 2 ln sine half theta, okay, plus c. Now I need the c. So for that, I know my x is equal to 1 and my theta equals to 1 over 3 pi. So I can simply say x equals to 1 and theta equals to 1 over 3 pi. So what I can do is I can put this as, so when I put 1 here in the place of x, I get this as ln 3 equals to, I get 2 ln sine of half into 1 over 3 pi. Make sure you're on the radian mode. Okay, so now I can write this as ln 3 equals to 2 ln. Now on the calc C, I can simply do sine of 1 over 6 pi, because 2 into 3 is 6. Okay, make sure you're on the radian mode. So when you do that, I get my answer basically as half plus c. Now I can use a log property here, which suggests that b log a is equal to log a raised to b. So using this log property, I can write this as ln 3 equals to ln half square plus c. So I can write this as ln 3 equals to ln 1 over 4 plus c. Now I can write this basically as ln 3 minus ln 1 over 4 equals to c. Now another log property here which states that log of a minus log of b equals to log a into b. So now I can simply write this as ln 3, okay, sorry, I wrote the formula wrong here. This is basically log a over b, sorry, my bad. Okay, so now this is ln 3 divided by 1 over 4 equals to c, which gives me my c as ln 12. So now writing everything together, I can write this basically as ln x plus 2, I'll need to scroll a little bit, equals to 2 ln sine half theta, 2 ln sine half theta, okay, plus ln 12, which is in the place of c. So now what I can simply do is, I need to write x in terms of cos theta. Okay, so for that what I'll simply do is, I'll first remove the ln. So for that there's a log property which I even stated before. That means that's b log a equals to log a raised to b. So using this property, I can basically write this as ln x plus 2 equals to ln sine square half theta plus ln 12. Okay, now another log property here which I can use, that's log a plus log b equals to log a into b. So now what I can do is, I can write this as ln x plus 2 equals to ln 12 sine square half theta. Okay, so now I can cancel ln on both sides, so I get x plus 2 equals to 12 sine square half theta. So I can write this as x equals to 12 sine square half theta minus 2. But now I need here x in terms of cos theta. So now you need to recall an important trig identity here, okay, which states that cos 2 theta is equal to 1 minus 2 sine square theta. So using this property, now I can say when this was 2, the coefficient here was 1, correct? So now I can say when I have cos theta equals to 1 minus 2 sine square half theta, because when this was 1, this becomes half, because here also it became the half, so even here it will become the half, correct? Basic conversion, we must have done this in the concept. So now what I can do is simply, I can write this as cos, I can make sine square half theta the subject of the formula, so it's 2 sine square half theta equals to 1 minus cos theta, where sine square half theta is equal to 1 minus cos theta by 2. Okay, so now what I can simply do is, in the place of sine square half theta, I can substitute this. So I get x equals to 12 into 1 minus cos theta over 2 minus 2. So now I get 2 ones are and 6 are. So x equals to 6 into 1 minus cos theta minus 2. So this is basically 6 minus 6 cos theta minus 2, which I can basically write as 6 minus 2 I know is 4. So I get 4 minus 6 cos theta, which is basically x in terms of cos theta. So you needed to know this basic trigo conversion here to get the sum right.